I said that this word finite to represent this finite automata comes from the fact that whatever computation we are doing, we represent state of that computation into finite number of states. And these states are actually created based on division of valid inputs into categories or partitions. Okay? Technically, they are referred to as partitions, but we can consider them as some sort of categorization. So we looked at what do you mean by partition set last lecture. So what is a partition set? Partition set is a set of all subsets of a set. Okay? Using these subsets, if I apply union operation on these subsets, I can reconstruct the original set, and individually these subsets are non-overlapping. So these are the two properties that makes a partition of that makes up a partition of a set. For example, we saw that if I unite Q1, Q2 and Q3, okay, Q1, Q2, Q3 को अगर मैं union करूँ उनका, then I can generate 5, 6, 8, 32, 2 and 9, which is the original set. But the set Q2 and Q3, they are overlapping. 32 is a common element between these two sets. So Q1, Q2, Q3 is not a valid partition for Q set. Okay. Whereas Q1, Q2 and Q4 is a valid partition, because if I do a union of Q1, Q3, Q4, I am going to get 5, 6, 8, 32, 2, 9, the original set. And there is no overlap between Q1, Q2 and Q4. There is no overlap between these three sets. Okay, so that is what we had looked at last lecture. So now some terminologies that needs to be covered before we go and jump and understand what do you mean by a finite automata. Okay, so as I told you, we'll be covering a lot of stuff from set theory that is going to come in handy. So I introduced few notations last lecture. One is this epsilon, okay, small epsilon. Epsilon is a Greek character. It's a small case character, and this is the way it is represented. The one which you are looking at. This represents an empty string. Okay, this always represents an empty string. It represents empty string. Okay. String is just the composition of various symbols from an alphabet. That is the notion of the word string for this subject. So whenever I refer to something as a string, it means it's a composition from the alphabet set, symbols in the alphabet set. Okay, alphabet set is represented as Greek capital letter sigma. So this is nothing but any alphabet set. Okay, alphabet set. These are standard notation, so there are definition you need. There is no definition as such for these. You just need to understand. Okay, then you need to understand another notation called as pi, which is going to be handy. Okay, so a 0 and a vertical line. This is again a Greek letter pi. I don't know whether it is cap or a small letter, but this is called as pi or null set. Okay. Now epsilon represents empty string. That is a string without any element inside it. Whereas pi represents a set which is having no element, or a null set. So null set is a set that does not have any element. Okay. So that is what pi means. Okay, what else I require? I require concept of a tuple. Okay, so what is a tuple? In any programming language or any other particular thing, tuple is collection of different things. So if there are two things which are part of a tuple, generally it is represented as a round brackets, and the elements are separated with a comma. Okay, if there are two elements in a tuple, it is referred to as a two tuple. Okay, if there are 5 elements, it will be called as pi tuple on the similar lines. I hope this is not needed to be explained. Why it is called as two tuple and why it is called as pi tuple. Okay, so it's a collection of 5 things. That is why it is referred to as 5 tuples. So 1, 2, 3, 4, and maybe this is the fifth thing. Overshoot. Just need 5 things. 1, 2, 3, 4, and 5. It's a round bracket. This is a 5 tuple because there are 5 elements. 1, 2, 3, 4, 5. Okay, they can be anything. So tuple के अंदर कोई भी data object हो सकता है. You remember this thing. Now, when I'm defining devices that we are discussing in this particular subject, these devices generally are in the form of declared in the form of a tuple that consists of different sets or different function mapping. ओके दो चीजें हो सकती है एक तो इन पर्टिकुलर एलिमेंट्स ये पर्टिकुलर एलिमेंट्स कोई दूसरे सेट्स हो सकते हैं ओके या ये एलिमेंट्स कोई तरह के फंक्शनल मैपिंग हो सकते हैं ओके फंक्शनल मैपिंग हो सकते हैं नाउ दिस टर्म मैपिंग इसका मतलब क्या है In terms of set theory, mapping refers to something of this sort. So if I suppose have a set 1, 2, 3, okay, and I have another set which is A, B, C, and if I have a set of tuples where I select one value from set 1 and another value from set 2, this particular set of tuples that I have created, this one is referred to as a map. So this is an example of a mapping. A map. So what we do in mapping is, so these are two sets, right? This is set 1. This is set 2. In mapping, what we do, we select an element from set 1 and associate it with an element from set 2. So mapping is what? Mapping is association between element from set 1 to any element in set 2. Okay. What kind of mapping I can have? I can have multiple different kinds of mapping. I can have one-to-one mapping. I can have one-to-many mapping. I can have many-to-one mapping. Okay, and I can have many-to-many mapping. What does these mapping means? One-to-one means any one element in this state set 1 will only be mapped to or related to exactly one element in the second set. So one element I select from first set will be mapped to exactly one element in the other set. It is called as one-to-one mapping. One to many mapping कब होगा कोई भी एक element at least one element from set 1 if it is mapped to more than one element in set 2. More than one element in set 2 से map का मतलब क्या I have a pair 1A and 1B in the map set. ये जो मैप वाला सेट है उसमें 1A भी है और 1B भी है ये दोनों पेयर्स अगर है तो वो हो जाएगा one to many mapping. So at least I have to have one S1 element that is connected to or mapped to or related to. आपको कोई भी वर्ड यूज करना है क्योंकि हम लोग सेट थ्योरी सिर्फ यूज करने वाले हैं सेट थ्योरी का डेफिनेशन कोई आपको नहीं पूछेगा just understand whenever someone says one to many means what इट्स अ मैपिंग तो दो सेट्स है एक सेट से दूसरे सेट को मैं रिलेट कर रहा हूँ या एक सेट से दूसरे सेट को मैं कनेक्ट कर रहा हूँ एंड द कनेक्शन इज इन व्हाट फॉर्म one element from the first set is connected to multiple elements in the second set that is called as one to many mapping. Then I have many to one mapping whereas one element from more than one element from first set is mapped to a single element in second set. So second set में एक ही element के साथ कनेक्शन है लेकिन पहले सेट में मल्टीपल एलिमेंट्स हैं दैट इज कॉल्ड एज मेनी टू वन मैपिंग सो नाउ एग्जांपल ऑफ मेनी टू वन मैपिंग क्या हो सकता है सो इफ आई हैव वन सेट ऑफ ऑल दी स्क्वायर टर्म्स जिसमें 4 भी आएगा और -4 भी आएगा स्क्वायर टर्म्स है राइट नॉट स्क्वायर सॉरी गलत किया मैंने all the numbers है शायद numbers है. Okay, all the positive and negative numbers. I have -2 in this set, and I have +2 also in this set. Now, if there is another set of numbers which is all positive numbers, 0 से start होगा ये set and it will run up to infinity. इसमें भी 2 आएगा, इसमें 4 भी आएगा. Now consider a connection between this -2 and this 4 and this 2 and this 4. These are connected together with a relationship called as square. If I do -2 square, I'm going to get 4. If I do 2 square, I'm going to get 4. Okay, there are two things, many things in set 1, which is connected to a single thing in set 2, which is 4. So this is called as many to one mapping. So -2 also square is 4 and +2 also square is 4. So we are mapping -2 and +2 to a single point or single number in the second set, which is 4. So that means I'm creating these pairs. So mathematically function क्या होता है? Creation of these pairs. This is what a function in mathematics is represented as. So I have these two pairs created. And there will be many more pairs like that. In fact, this particular mapping will be an infinite mapping. So mapping can be infinite, mapping can be finite. Okay, I can have an infinite mapping, I can have a finite mapping. Say suppose I want to map your roll number to your name. So there will be a set of roll numbers, which is a finite set, a set of names, which will be finite set, and what kind of mapping it will be? It will be one-to-one mapping, because one person will have one roll number, right? One name will be mapped with one roll number. So it will be one-to-one mapping and a finite mapping. So I can say that whenever I am creating a relation, I am actually creating a mapping. I am creating such pairs of connections from first set to the other set. Okay, and when I am creating such pairs, such connections, there are four ways in which I can do these mappings. I can have one-to-one mapping, one-to-many mapping, many-to-one mapping, and many-to-many mapping. Okay, so this is the concept of mapping in set theory. So function is also a kind of mapping. Function is also kind of mapping. अभी जब मैप करते हो ना, तो क्या हो सकता है कि सेकेंड वाला जो सेट है उसमें से कोई एलिमेंट मिस हो सकता है. Okay? उसमें से कोई एलिमेंट मिस हो सकता है, राइट? दैट मीन्स there could be one element in set 2 which is not related to any element from set 1. अगर ऐसा मैपिंग है तो उसको इनटू मैपिंग बोला जाता है. इस चीज को इनटू मैपिंग बोला जाता है, बिकॉज आई एम मैपिंग इनटू द सेट. There is some element from set 2 which is not considered in any sort of tuple. Okay, कोई भी tuple में उसको consider नहीं किया गया है. अगर ये situation है तो it is called as into mapping. So I can have 1-1 into, one to many into, many to one into, many to many into kind of mapping. Or there is other kind of mapping called as onto. So onto यानी पूरा का पूरा set 2 is participating in the relationship. Okay, please understand, whenever I say a mapping is onto or into, I am not considering कि set S1 का participation है relation में या नहीं, लेकिन मैं S2 के सब एलिमेंट का पार्टिसिपेशन रिलेशन में है या नहीं इसके बारे में कमेंट कर रहा हूं. अगर कंप्लीट S2 इज पार्टिसिपेटिंग इन द मैपिंग, दैट इज all the elements from S2 are there in the tuples as second elements. Okay, if I find the unique elements in the second elements of all these set of tuples which are part of the mapping, then such mapping is called as onto mapping. If some of the elements are missing from S2, okay, then such mapping is referred to as into mapping. So I can have 1-1 onto mapping. That means there is one-to-one correspondence and every element in set 2 is participating in the mapping. For instance, the example of set of your roll numbers and set of your names will be an one-to-one correspondence. Okay, the relationship between the first set element and the second set element is 1-to-1, and the mapping is onto. That is, all the elements in your name set are participating in the relationship. Okay, I hope these concepts are clear to you. So these functional maps could be there, sets could be there in this tuple representation. I can have some elements